Kamal has 30 hens. Probability that any hen lays an egg on any day is 0.7. Hens do not lay more than one egg per day, and the days on which a hen lays an egg are independent. Calculate the probability that on any particular day, Kamal's hen lay exactly 24 eggs. So 24 out of the 30 hens should be laying eggs. This is the case of binomial distribution. 30 C 24, probability of success, which is 0.7. This happens 24 times. Probability of failure, which is 0.3. This happens 8 times, so power 8. This would give us, sorry, not 8, 6 times, which gives us 0.082928, which we round to 3 significant figures and get 0.0829. Part 2. Use a suitable approximation to calculate the probability that Kamal's hens lay fewer than 20 eggs on any particular day. Suitable approximation means this is a question on converting binomial distribution into normal distribution. For that, we must first apply continuity correction. Says lays fewer than 20 eggs, so we can write E less than 20. Then we will apply continuity correction, so E less than 19.5. Since it's less than, we're going to use lower bound, which is 19.5. So now we apply standardization by subtracting mean and dividing the standard deviation. So now this becomes Z. Less than 19.5 minus mu upon sigma, subtracting the mean and dividing the standard deviation. Okay, mean in binomial distribution is equals to n times p. N is 30 and p is 0.7, which gives us 21. And standard deviation is equals to square root of np1 minus p or npq. So that is 30 times 0.7 times 0.3, which gives us square root of 6.3. So now we'll get probability Z is less than 19.5 minus 21 divided by square root of 6.3, which gives us probability C is less than negative 0.59761. Okay. Z-score is needed till 3 decimal places only, so this will be minus 0.598. This will be rewritten as 1 minus 5, 0.598. So 1 minus, let's find this probability. What's the probability against the Z-score of 0.598? 0.59 is this. And add an 8 to it. 8 means add 27 to it. So 0.7224 plus 27 gets added to the last two digits, which gives us 0.7251. So 1 minus 0.7251, which gives us 0.2749. And this is an estimated probability. So we're going to round this off to 3 significant figures, 0.279. Question number 7. In a normal distribution, 69% of the distribution is less than 28. So probability x is less than 28 is equals to 0.69, and 90% of the population is less than 35. So probability x is less than 35 is equals to 0.9. Find the mean and standard deviation of the distribution. So we're going to standardize this by subtracting mean and dividing the standard deviation. Same here. When you standardize, the x becomes z. Okay. Now we're going to check if any of this z-score is negative, which I doubt. Here in the center, we have 0, and if z is less than 0, the probability is 50%. But here the probability is more than 50%, it's 69%, 0.69. So that means we'll shade this part of the graph, and this value of z is positive because it's at the right side of 0. Now let's check for this one. Here it says probability same here. So it's 90% or 0.9. So it's somewhere over here. And this part gets shaded. So again, this z value is towards the right of 0. So it's positive as well. Okay. So now we're going to find the z scores corresponding to the given probability. First probability is 0.69. Let's go to the table. We need to find the probability 0.69. We can't find that exactly. It becomes greater than 0.69, but we look at the value less than 0.69, which is 0.6879. Now, ideally, if we add 21 in the end, we will get exactly 0.69. But we don't have 21. We can add 18 or we can add 22. If we add 18, we'll get 0.6879 plus 0.0018, that gives us 0.9897. And if we add 22, we get 0.6901. Now both are not exactly 0.69, but marking scheme is accepting both. So for this one, the z-score comes out to be 0.495. And for this one, the z-score would be 0.496. So the marking scheme is accepting both. So I'm going to use 28 minus mu over sigma. I'm going to use the smaller one, 0, or we could use the bigger one because it's more closer to 69% than the other one. So 0.496, and here we need to find the z-score corresponding to 0.9. Again, you won't be able to find exactly 0.9 in the probability table. However, notice that at the bottom of the table, you're given the z-score corresponding to 0.9. So always, whenever you can't find a particular probability in the table, always look at this bottom table. So it's 1.282. So 1.282 is the z-score. So 35 minus mu over sigma is equals to 1.282. Now we have to solve these simultaneously. The simultaneous solution carries 1 mark. So this could be equation 1, and this could be equation 2. Okay, so now it's up to you if you want to use, oops, I forgot the sigma. It's up to you whether you want to use elimination or substitution. I'm going to use substitution. It's 28 minus 0.496 sigma is equals to 35 minus 1.282 sigma. Okay, you solve this, make sigma the subject, you will get 8.905, around something like that. And then in 3 significant figures, it becomes 8.91. And similarly, when you substitute it back, you'll get mu to be something around 23.59, which rounds off to 23.6. The length of time a person undergoing a routine operation stays in hospital can be modeled by a normal distribution with mean 7.8 days and standard deviation 2.8 days. Calculate the proportion of people who spend between 7.8 days and 11.0 days in the hospital. We have to find the probability that a person stays between, we can call this days or X, between 7.8 to 11.0. Okay, now we will standardize this by subtracting the mean and dividing the standard deviation. X becomes Z now. Sorry, the standard deviation is 2.8. Okay, so we get a 0 here and we get 1.14285 here, but z-score is only needed till 3 decimal place, so 1.143 is good enough. Okay. Now we're going to use the normal distribution rule that when we have a range of values given like this, we find the probability that z is less than 1.143 minus probability z is less than 0. Okay, so let's find the probabilities for both of these z-scores, 1.143 and 0. Okay, so when it's 1.143, 1.14 is here. So this is the probability, and sorry, this is the probability, and we have to add 3, which means we have to add 6 in the end. So 0.8729 add 6 in the end. This gives us 0.8729 plus 0.0006. It gives us 0.8735. 0.8735 minus probability when the z-score is 0, that's 50% or 0.5, right from here. 0.5, which gives us 0.3735. Since these probabilities are estimated probabilities, we can round it further to 3 significant figures, which gives us 0.374. Part 1 is done. Part 2. Calculate the probability that the 3 people selected at random, that from the 3 people, that of the 3 people selected at random, exactly 2 spend longer than 11.0 days in the hospital. So this is the case of binomial distribution. We'll do 3C2. Probability of success will have a power of 2. Probability of failure, which is usually represented by Q, or 1 minus P, will have a power of difference of 3 and 2, which is 1. Okay. Now, what's P and what's Q? P is the probability that the person spends longer than 11.0 days in the hospital. So, probability Z is greater than 11, and we also standardize 7.8 over 2.8, which we've already calculated, by the way. So probability Z is, let's use this, greater than 1.143. This is 1 minus 5, 1.143, which was already calculated. It's right here. So 0.8735, 1 minus 0.8735. which gives 0.1265. So we're going to use that here. So 3C2, 0.1265 power 2, 1 minus 0.1265 power 1. This will give us 0.0419 after rounding. Part 3. A health worker plotted box and whisker plot of the times that 100 patients chosen randomly stayed in hospital. The result is shown in the diagram. State with a reason whether or not this agrees with the model used in part 1 and part 2. Okay, in part 1 and part 2, we used normal distribution and binomial distribution, both of which are a symmetric distribution. Normal distribution looks like this, and uh, binomial is a discrete variant of normal distribution, so it looks something like this. So both of these distributions are very symmetrical. However, we notice that this is not a symmetrical distribution. If it were symmetrical, we would have something like this roughly. We don't have a symmetric distribution here, so we'll write that it does not agree with the model used in part 1 and part 2 because the box and whisker plot is not symmetrical. So part 3, no, because box and whisker plot is not symmetrical. And this question is done. Question number 9. Melons are sold in 3 sizes, small, medium, and large. Weights follow a normal distribution with mean 450 grams and standard deviation 120 grams. Melons weighing less than 350 grams are classified as small. Find the proportion of melons which are classified as small. Okay. So, if the melon weighs less than 350 grams, it's classified as small. We're going to standardize that by subtracting the mean, which is 450, dividing the standard deviation, which is 120. This gives probability Z is less than 350 minus 450, answer divided by 120. It gives us minus 0.83333, so on. Z-score is required till 3 decimal places. So we're going to use this. Okay, this will be converted into 1 minus 5, 0.8333. Let's read the probability and then we'll subtract 1 from it. So 0.8333, what's the z-score corresponding to that? 0.8 is here, 3 is here, 0.83 and another 3, which is this. So 0.7967 plus 8 in the end. So 0.7967 plus 0.0008, which gives us 0.7975. So 0.7975. Okay, I'm sorry, in 3 dp, it's going to be 0.833. Okay, so 1 minus answer is 0.2025. And since all these probabilities are estimated probability, we'll round off our final answer to three significant figures, which become 0.203. So these proportion of melons are small, classified as small. Okay. Part two, the rest of the melons are divided in equal portions between medium and large. That means the rest of it would be 1 minus 0.2025 and then divide it with 2 to get the proportion of medium lemons and large lemons. So 1 minus answer divided by 2 gives us 0.39875. So this is the proportion for both medium and large lemons. Okay. Now, the rest of the melons are divided in equal proportions between medium and large. Find the weights above which models are classified as large. So probability X is greater than certain grams is equals to 0.39875. And we have to find this value of A in grams. So we're going to rewrite this as 1 minus 5, A equals 0.39875, which is rewritten as phi A equals 1 minus answer, which gives us 0.60125. Now we need to find the z-score corresponding to this probability. Now probabilities are written correct to 4 decimal places, so we can round this off to 4 decimal place, 0.06013. Okay, let's find the z-score corresponding to this probability, 0.6013. Okay, so we have 0.6 here, 0.60 here, and 13. Okay, so we need to add something to this to convert it into 0.6013. Okay, so we need 0.6013. For that, what do we need to add to this? Let's subtract these quickly. 0.6013 minus 0.5987. That gives us 20. Hold on, I might have made a mistake. Yeah. Yeah, that gives us 26. So we need to add 26 to the last two digits, but there's a problem. We don't have 26 available. We have 23 available and 27 available. So in this case, we're going to use the one that gives us the closest probability, which we'll get through 27. So when we add 0.5987 and 27, we'll get 0.6 something, which would be 0.6014. So this is pretty close to 0.6013. So we're going to use the z-score of 0.357. So, sorry, 0.257, my bad. This is 0.2, then 5, and then 7. So let's use that. Okay, so A is going to be equals to 0.257, which was the z-score. However, I just realized a big blunder that I forgot to standardize this. So I have to subtract mu and divide with standard deviation, which I forgot to do. I'll do that here. Mu was 450, so minus 450, and standard deviation was 120. Okay, so we've done that now. Now we're going to find the value of A from here, which will come out to be around 480.84, and we round it off to three significant figures, so we get 481. A shop sells 8 videotapes, of which 1 in 5 on average are known to be damaged. That means probability that a tape selected would be damaged is 1 by 5, and probability that it's not damaged would be 4 by 5. A random sample of 15 tapes is taken. Find the probability that at most 2 are damaged. So that means none are damaged, or 1 is damaged, or 2 are damaged. This is binomial distribution. So we'll start with 15C0. This means none are damaged. So damage probability power 0, not damage probability power 15 minus 0, which is 15. Plus, out of 15, 1 is damaged. So damage probability power 1, not damage probability power 14 from 15 minus 1. Then 15C2 damaged power 2, not damaged power 13. Add all this up in your calculator. And we get 0.398 after rounding to three significant figures. Part 2. Find the smallest value of n if there is a probability of at least 0.85 that a random sample of n tapes contains at least one damaged tape. Okay. At least one damaged tape means that there could be 1 or 2 or 3 or 4 or all the way up till 15. So instead we'll do 1 minus probability that there is no damaged tape. And this probability is at least 0.85. That means greater than equals to 0.85. Okay, so this would be 1 minus, or yeah, this becomes 0.15 first. And I'm moving the probability to the other side. Probability x equals to 0, which is 0.15 greater than equals to, this will be 15C0. Probability of being damaged was 1 by 5, and probability of not being damaged was 4 by 5, and the power of that will be 15. So 0.15 greater than equals to 15C0 is 1. This is also 1. So we get uh, sorry, it's 15, not 15. This time it was N. I don't know why I took 15 from the last part. It's NC0 because it says that N tapes from that a random sample of N tapes. So it should be NC0, 1 by 5 power 0, 4 by 5 power N minus 0, which is N. Okay, so we get 0.15. NC0 is just 1. Anything C0 is 1. And anything power 0 is also 1. So 1 times 1 times 4 by 5 power n. Okay. Now to find n, we'll use log. So I'm going to use log. You can take any base. I'm taking 10. Is greater than equals to n log 4 over 5. You could take log or ln or whatever base you want. Okay. So log 0.15 is a negative value. You need to be very careful about what you're dividing with, because if you divide with a negative value, you will flip the inequality sign. n here, and what is log 4 by 5? It's also a negative value, minus 0.09691. Okay, now we divide both sides with negative 0.09691. Remember that will flip the inequality sign. And now I'm going to divide these two, which would give me 8.501. So the next integer is 9. So 9 should be the answer. You need to be very careful when you're solving a log inequality. You need to definitely check the sign of this. If it's negative, you're dividing with a negative value and you'll flip the inequality sign. If you don't check the sign in this case, you will end up with a positive answer, and if you directly divide these two, if you do log 0.15 divided by log 4 over 5 directly, you wouldn't know that you divided with a negative sign, because the answer is just coming out to be positive, because negative and negative cancels out, gives you a positive. So you wouldn't know that there was a need to flip the inequality. So always in log, check what you're dividing with. Find the decimal value of this to ensure that if that's a negative number, the inequality sign will be flipped. All right, part 3. A random sample of 1600 tapes is taken. Use a suitable approximation to find the probability that there are at least 290 damaged tapes. Okay, so use a suitable approximation means we're converting binomial into normal. So probability that there are at least 290 damaged tapes. So x is greater than and equals to 290. Now we'll apply continuity correction first. So this is the upper bound case. So we write greater than and equals to, uh, no, this is a lower bound case, I'm sorry. When it's greater than and equals to, consider it as not greater than. And then it becomes lower than, which is lower bound. So we use 289.5. Remember, greater than equals to is lower bound. Only greater than is upper bound. Similarly, if it were just lower than, we would have used lower bound. But if it was lower than and equals to, then we would have used upper bound. Okay, now we'll also have to apply continuity correction. X is greater than 289.5 minus mu upon standard deviation. Mu would be the same as the mean of binomial distribution, which is n times p. N is 1600 tapes, and p was the probability of damaged tape, which was 1 by 5, which gives us 320. And standard deviation is equals to square root of np times 1 minus p. So 1600 into 1 by 5 into 1 minus p is 4 by 5. This gives us exactly 16. So we'll write probability. In fact, this x here becomes z after we apply standardization. So z is greater than equals to 289.5 minus 320 upon 16, which gives us negative 1.905. Let me quickly check if that's the case. 289.5 minus 320 divided by 16. Yeah, minus 1.906 actually in 3 decimal places. Z-score is required till 3 decimal places. Okay, now we know that this is the same as phi 1.906. So we'll read the probability corresponding to 1.906. 1.9 is here, 0 is here. So this 0.9713 and 6 is 4. So we add a 4 in the end. So 4, 5, 6, 7, 1, 7, 9. So 0.9717. So 0.9717. But since this is three significant, this is an estimated probability, we round it off to three significant figures.